Your customer just clicked Add to Cart on your website. That click happened in real time right now, this instant. But when will your inventory system know about it? When will your analytics dashboard show the updated metrics? The answer might surprise you. What do we mean by data generation? We are not talking about creating synthetic or fake data for testing purposes. Instead, we're focusing on how real-world events like customer interactions, sensor readings, and system logs naturally create data as they happen. This is the first phase of the data engineering lifecycle, where data originates from actual business operations and user activities. All data comes from real-world events happening right now. Every customer click, every purchase, every sensor reading, these are all events occurring in real time. But even though data is generated in real time, you often can't access it in real time. Your systems might only sync every 30 seconds or every hour or even daily. The data generation is real time, but your access to it is batched. The real question isn't, how do we generate real-time data? It's, how can we build systems that take advantage of real-time data generation, even when external constraints limit our access to it? The way to solve this challenge is by building event-driven systems that are designed for real-time processing from the ground up. If you design your system assuming data will arrive continuously and in real time, you make it truly event-driven. It can process data as soon as it arrives, not on a predetermined schedule. When you are forced to work with batch data due to constraints outside your control, process each batch immediately when it arrives. You still process the events as though they were arriving in real time, even though they have arrived in batches. The beauty of this approach is that when those constraints are eventually removed, your system will scale seamlessly because it was designed to be real time from the start. But why does this event-driven approach work so well? It's all rooted in the fundamental nature of data. Every customer click, every purchase, every interaction is happening right now as we speak. Users click buttons, sensors take readings, and systems generate logs, all based on events that occur in real time. When we build event-driven systems, we are not just choosing a convenient architecture, we are aligning our systems with how the real world around us operates. Data doesn't appear on a schedule. It happens when actual real-life events happen. When we design our systems to process data as events arrive, we are working with the natural flow of data, not against it. This is why event-driven systems are so effective. They match the reality of how data is generated. This is a crucial insight that we often miss. You don't control the world around you. These events happen whenever they do, and your job is to capture and process them. But the lack of control goes even deeper. In most organizations, you don't control when data is generated. You don't control how it's formatted. You don't control when it becomes available. Product teams generate data through applications. Infrastructure teams generate monitoring data, and you are just a downstream processor trying to make sense of it all. As a data engineer, you are expected to build real-time systems around data generation that you don't control. The data comes when it comes and not when you are ready for it. Okay, but where does all this generated data actually get stored? When a user makes a purchase, that data gets recorded in a database. When a sensor takes a reading, it gets written to a file or sent to a message queue. When an application encounters an error, it gets logged. The data gets stored in the operational estate. These are the systems that run your business day to day. These operational systems are designed to capture and store data immediately as it's generated. They are not designed for analytics or reporting. But this is where your data pipeline starts. You are going to take data from these operational systems and transform it into something useful for processing and analysis. Let's look at some concrete examples of how this data generation and recording actually works. User interactions are perfect examples of data that you do control. When someone clicks a button on your website or submits a form, you can capture it immediately and process it in real time. This is the ideal scenario. Data generation and access happen simultaneously. Application logs, error messages, performance metrics are other examples of data with direct access. Your servers generate log entries continuously, and since they are on your infrastructure, you can stream them directly into your data pipeline. But not all data is this accessible. Take the smartwatch example. Every second, sensors are measuring heart rate, GPS is tracking location, and the device is counting steps. This data is generated continuously in real time, but it might not be transmitted in real time. The smartwatch might store this data locally and only sync when you are near your phone or Wi-Fi. So, while the data generation is real time, your access to it is delayed. This is a common pattern with IoT devices and mobile applications. The glucose monitor is taking blood glucose readings every 30 seconds. That's real-time generation. But you are not near your phone. It stores that data locally for up to 8 hours before syncing. So the generation is real-time, but the transmission is delayed. This creates a gap between when data is created and when you can access it. Medical devices often face connectivity constraints, so they prioritize data collection over immediate transmission. And lastly, the wind turbine. It's constantly monitoring wind speed, temperature, and performance metrics, but it might only transmit data every 15 minutes due to network limitations. But when that 15-minute batch arrives, you should process it immediately. Don't introduce any artificial delay through hourly or daily batch jobs. Your system should be designed to handle data at any frequency, so when constraints are eventually removed, when you get better connectivity, your real-time processing will scale seamlessly. The common thread and key takeaway in the examples we saw is that while you don't control when you get access to the data, when data arrives, you should do your best to process it right away. Whether data comes in every second or every hour, the processing pipeline should be ready to handle it the moment it arrives.